Welcome to the remediation for Unit 10. It says, what does the conservation of charge mean? The conservation of charge means that whatever the charge you have at the beginning must be the total of the charge at the end, although those charges can rearrange themselves. So for example, if you have something that is like 8 coulombs of charge, you can split those 8 coulombs of charge into plus 5 or plus 3 because that adds up to 8, or plus 10 and minus 2. But no matter what you split them as, the total has to equal the original. Now it says, what is the origin of all charge? The origin of all charge is in the protons and electrons of the atom. The protons provide the positive charge, and the electrons provide the negative charge. Next, it says, list the charge of each object after the sphere is split, as shown below. So whenever you split the charge, it tries to split the charge as equally as possible. So when I have a 12 millicoulombs, that means I'm going to have plus 6 over here and plus 6 over here. Now there are circumstances in which that's not going to be the case, but most of the time the charge is going to split equally. And regardless, this right here has to equal the original charge. What are the three methods of charge transfer? You have conduction, you have induction, and you have friction. Now, what determines how charge is transferred? And what that is that is the contact. Okay, are you contacting a charged object? Are you removing electrons via friction? Or is there no contact? And that will determine whether or not you are transferring charge by one of these three ways. So give a real life example of how charge is transferred in each. It's gonna vary based on you, but you could have something like dragging feet for friction. You could have something like sticking a fork in an electrical socket, which do not do. Electrical socket. Okay, and you could have something like induction could be something like lightning. That is how lightning is created, the idea that you have a difference in charge without touching. Okay, next it says write an equation for Coulomb's law. The equation for Coulomb's law is F equals K Q1 Q2 over D squared. Sometimes it's R depending on the book, but it's the distance. So now we want to know which variable has the greatest impact on the magnitude of force. Remember, magnitude refers to the number. So once you know that it's the number, you should realize it's distance. The units of coulombs, okay, the value of Q, both 1 or 2, are how you would get coulombs. Constant is a unit of K, that's always the same value. And responsible for the direction of the force is Q1 and Q2. You should be able to take this right here and understand that this subatomic particle must be an electron, and you should be able to justify it using the clear method. Now it says what units should be used in order to get the 8.99 times 10 to the ninth value. So in order to use that K value, you're going to have force be in newtons. You're going to have Q1 and Q2 both need to be in coulombs. And then the distance term needs to be in meters. If you use any other terms or any other values, you wouldn't be able to use the 8.99 times 10 to the ninth. Now it says calculate the electrostatic force between two electrons, and you're given this right here. Remember, the electrostatic force is going to be using Coulomb's law. And when you plug those values in, make sure that you plug them in as given and that you square the distance term. Okay, whenever you do that, and you look and it says, well, it only gave me the charge of one electron, but it gave you two identical electrons. So you have both your Q1 and your Q2 value being the same value. Okay, now when you do this, you should end up getting a number on the order of 1.02 times 10 to the minus 8th, and we were calculating force, so that's the newtons. Next it says calculate the identical positive charges that exert a repulsive force of 10 newtons when separated by 0.5 meters. Okay, whenever you do this, if you do it correctly, you should come up with a value of about 1.67 times 10 to the minus 5th coulombs. Now, what is the difference between K and G? Well, K is the electrostatic constant, and the electrostatic constant is a very, very large value, indicating that the electrostatic force is very strong. G is the gravitational constant, and it is very, very small, indicating that gravity is a very weak force. So how does distance affect both the same? If you look, both of them are inverse squares. Both gravity and the electrostatic force have this d squared term on the bottom. So because of that, they're both negatively affected, not negatively affected, as the distance goes up, the force is going to dramatically decrease. And then finally it says, how does the force of gravity compare? You should know that gravity is always attractive, and you know that the electrostatic force can be either attractive or repulsive depending on the orientation of the charge. Opposites attract, like charges repel. Okay, if you have any questions about this, we'd like you to go ahead and move on towards the independent practice, but if you have any questions, make sure you see your teacher before moving on.